What are common GIS data format problems in archaeology? Imagine trying to piece together a giant puzzle where some pieces are missing or don't quite fit. That's similar to what archaeologists face when working with GIS data formats. Geographic information systems are essential for mapping and analyzing archaeological sites, but they come with their own set of challenges. Let's explore what can go wrong and how to fix it. First, archaeologists work with different types of spatial data. There are vector data, which include points, lines, and polygons representing artifacts, site boundaries, or excavation zones. Then there are raster data, like aerial images or environmental models stored as grid-based files. Problems happen when these data types are stored in incompatible formats. For example, if a site boundary polygon is saved in a format that doesn't support attribute data, important information might be lost. One common issue is coordinate system and projection mismatches. Data collected with GPS devices or from various sources often use different spatial references. If layers are not properly georeferenced, or if their projections don't match, the maps can be off. This can lead to errors in analysis, like misplacing artifacts or misaligning site features. Rectifying aerial photos to ground truth GPS data requires careful handling to ensure everything lines up correctly. Missing or incomplete metadata is another problem. Metadata describes how data was collected, its accuracy, and its processing history. Without it, it's hard to judge the quality of the data or to reproduce results later. Archaeologists need to document details like the date of collection, the equipment used, and any transformations applied to the data. This helps keep the data reliable over time. File format compatibility also causes headaches. Different software platforms may not support all data attributes or spatial components. When transferring files between programs, some data might get lost or corrupted. For example, attribute tables linked to spatial features may not transfer correctly if formats are incompatible, leading to missing information. Handling large datasets is another challenge. High-resolution raster maps or extensive survey data can be very big in size. Managing these files requires efficient storage and processing methods. If not optimized, software can slow down or crash during analysis. Using raster-based methods or compressing data can help manage this. Archiving data properly is vital for future use. Archaeologists should store not only the spatial files but also attribute tables, projection files, and documentation. If any of these are missing, the data might become unusable later. Proper archiving ensures that future researchers can understand and use the data correctly. Finally, visualization and interpretation can be affected by how data is processed and displayed. Applying filters or transformations might hide or distort archaeological features. If these steps aren't documented clearly, it can lead to biased or incorrect interpretations. To avoid these problems, archaeologists should always check that all data layers are correctly georeferenced, use open and supported file formats, keep detailed metadata, archive complete datasets, and be transparent about any data processing. Addressing these issues helps ensure that spatial analysis is accurate and that archaeological information remains accessible for years to come.